Hello. Today we're going to talk about graphing roots, like square roots, cube roots. It all falls under the same umbrella. So here's the idea. The idea is make a table. That's it. Just make a table. And then pick points. And then plot them. Okay, but there's a couple things that can make your life easier. First of all, I picked this first one. Y equals a square root of x. Now, when we're taking a square root, one thing that's not possible is taking the square root of a negative. We know that the square root of -1 is an I. It equals I. It's an imaginary number, and you can't graph it on a coordinate grid. So, you notice for when x is -1, there's no solution. You can't get it. So what is the smallest value you can square root? Turns out it is 0, right here. So when I plug in a 0 in for x, the square root of 0 equals 0. Great. So y, so 0, 0. First point. This is where it begins. After that, 1 square root of 1 is just 1. Very nice. Over 1, up 1. But notice when I go over 2, the square root of 2 is not pretty. It's an irrational number. It's over 2 spots, up 1.4-ish. 3, the square root of 3 is about 1.73. Over 4, up 2. Oh, finally, a nice integer. 5 is up 2.23. 6 is 2.44. And you notice the curve. And so the more points, it's going to get irrational, the more accurate your graph is. But ideally, what you want to do, you don't necessarily need to get all these points, but it's nice to find your rational one. So the last one I'd probably plug in would probably be 9, because I know the square root of 9 is a 3. And if I go over 9 spots and up 3, the nice part is, according to my graph, it gives me something to kind of shoot for. And so now I can draw my graph pretty accurately as that. Now, you notice that the graph of the square root of x is the inverse of a quadratic. It is the inverse of a quadratic. And so this graph is going to look like a parabola, but it's tipped on its side. It's reflected over that identity axes. So you're going to notice it's going to look like a sideways parabola, but to remain a function, it has to pass the vertical line test. You're only going to have half of it, because when you square root, you don't get plus and minus. You only get just that value. You can't get square root negative. So that's what we're doing. Now, what is the most important part? Well, it's finding where this point starts. So if I start with this y equals the square root of x minus 1 plus 3, I can't necessarily plug in 0. If I start with 0 and I put a 0 in the x spot, 0 take away 1, what's the square root of -1? Imaginary. No solution. You can't do it. So I got to find the spot. So this is going to be the most important thing for you to know, is when you graph, how do I find the very first point? And so what you're going to do and what you're going to look for is what is underneath the square root. Now, I'm not paying attention to the plus 3. That's not going to help. Right now, I want to know what makes x minus 1 equal to 0, because that is where my domain is going to start. Now, I can solve it. I can go plus 1, and you notice x equals 1. Then that is the first point I'm going to start with. So when I plug in a 1, 1 minus 1 is 0. Square root of 0 is 0. 0 plus 3 is 3. There is my first point. Over 1, up 1, 2, 3, right here. Okay, so that's where this thing starts. Now, the domain, I can pick biggers. I can pick numbers like 2. I can go 2 minus 1 is 1. Square root it is still 1. 1 plus 3 is 4. And I can still plot these points. Anything bigger than that, No problem. So your domain starts at this point. How do I write my domain? I'm going to say that my domain, x, has to be greater than or equal to 1. Because when I solved it, when I found what's under the square root, it's the square root. That's kind of that limiting factor. Okay, so next we're going to plot a few more points in here. We got to pick 2, 4. After that, it's going to get kind of messy. So I can pick 3 and get a irrational number. That is okay, but ideally, I'm going to try and pick values that give me nice square roots. So square root of 4 is really nice. How about if I pick x to be 5? If I go 5 minus 1, I get a square root of 4, which is 2 plus 3. So if I plug in a 5, I end up with a 5. That's not too bad. Next one, what else would be nice? This 9 minus 1. What if I put in an, let's see, I'd have to go 10. Whew, I would do the opposite. Here we go. If I plugged in a 10, and I go 10 minus 1, I get 9. Square root of 9 is 3 plus 3 is 6. Now that I have a few of these nice points, I can plot them. So 1, 3, 2, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 here, and 10 up, 1, 2, 3, 4, 5, 6. I have enough points to get an idea where this graph is. And knowing the shape, this is kind of this parabolic shape, is what the square root is going to look like. Okay? Now notice it's going up higher and higher. Since this is going up higher and higher, it'll go forever. It'll just keep on going up like a parabola extends out forever, but it'll grow kind of slow. So range, we need to know from this spot, where was our starting point? It was right here. And so where did it start? It started up at 3. And so my y has to be greater than or equal to that 3. Now, if there was a negative sign, say there's a negative sign out front here, all these values would have been flipped, and these values would have gone lower, then you might switch this sign down here and say y would have to be smaller than or equal to that 3. And so that's why it's important to make your table first and then get an idea what it looks like. Then you can make your domain and range. Remember, domain and range are just what values are possible to plug into this function, and the range is what values do I get out of it. So y can be anything greater than or equal to 3. So it can be irrational, absolutely, anything bigger. So the last one I'm going to talk about, and then I'm going to let you guys go for it, is what happens if I have an inequality sign. Well, guess what? Same thing as always. You're either going to have a solid or dotted, or you're going to shade. So looking at, just one more time, I'm going to start with inside the square root, what x minus 4, what makes that equal to 0? Plus 4, just solve it, x equals 4, okay. So 4 is where I'm starting. And so then if I plug it back in, a 4 minus 4 is 0, square rooted is 0, plus 1 is my first point. After that, you can plug a few more points in, and so what are we going to pick? How about 5? Go by 5. 5 minus 4 is 1, square root of 1 is 1, plus 1 is 2. Next one, what about 8? 8 is nice. 8 minus 4 is square root of 4 is 2, plus 1 is 3. Now, I would keep on going, but my graph only goes till 10. So I'm going to be off the graph pretty quick. So my starting point is over 1, 2, 3, 4, up 1. And then after that, it is over 5, up 2, over 8, up 3. And then I got to take a look. Is there an equal bar on this? If there is, I'm just going to connect it with a solid line. If there's not, I need a dotted line. So don't forget about dotted lines, solid and dotted. But the next part becomes shading. And so my favorite point to shade is this point, 0, 0. But in this problem, this is inside the negatives, the square root. My function doesn't start until all the way over here. So I can't test 0, 0. I need to test something else. So maybe I will pick, for something different, I'm going to pick 10, 0. This is my test point. Do I want to pick 10? Maybe I'll pick something nicer. How about that one? 8, 0. I like that. Why am I changing it? I started picking a random one, 10, but you know what? 8, 0 is a better one, because when I plug this into my original equation, and I put an 8 in the x spot and a 0 in the y spot, and I look to see if it's true, I want it to be easy. I want 8 minus 4 to be a nice square root. 8 minus 4 is 4. Square root of that is 2. 2 plus 1 is 3. So now is 3 greater than 0? True. If it is true, yay, it's true, then this point here, 8, 0, gets shaded, which means all the points next to it gets shaded. 10, 0 gets shaded. Everything next to it, underneath this graph, gets shaded. Now here's what I want to tell you about. It's not until the bar line, this is everything down here is going to get shaded. But there is an imaginary line right down this point that we're not going to shade to the left at all. We're only going to shade underneath it, because our domain does not start until 4. So we have to be aware of that for shading. So only shade underneath your line, underneath that. You can't shade to the left, can't shade to the right. Now, if this did not work, I would shade the top of that green line, but in this case it was true, so that point gets shaded. And that's what we are doing. Hope this helps. Have a great day. Good luck.